Okay, so let's unpack this. I want you to picture the absolute peak of a scientific career. I mean, the phone call from Sweden, the gold medal, the banquet, being written into the history books right next to, Einstein and Curie. And in 2024, that is exactly what happened to Demis Hassabis and the team at Google DeepMind. They took home the Nobel Prize in chemistry.
It's the summit. There is literally no higher honor in the scientific world.
And if you were following the news when it happened, the story was, well, it was very specific. It looked like this lightning strike of genius.
Right.
Like artificial intelligence just walked into a room and poof, solved one of biology's hardest problems overnight.
The eureka moment. We love that story, don't we? The apple falling on Newton's head, the lightning and the kite. It's dramatic.
It is. But today, we're looking at a source that just completely dismantles that whole lightning strike myth. We are doing a deep dive into a review by Gaurang, Korea, dated just a few days ago, January 17, 2026. And he's reviewing a documentary called The Thinking Game.
And this review is fascinating because it argues that the Nobel Prize wasn't a sudden event at all. It was the result of a decades-long obsession. And crucially, it suggests that the path to this incredibly serious scientific breakthrough, it didn't start in some sterile lab. It started with video games.
This is my favorite part of this whole thing.
Yeah.
We're talking about the bridge between play and science. So our mission for this deep dive is to figure out how a unique philosophy and, frankly, a love of gaming led to solving a 50-year-old biological puzzle.
Yeah, it's a story about strategy and geography and what it really means to solve a hard problem.
So let's jump right into the sandbox. The source mentions that if you watch The Thinking Game, the first thing that hits you is that it doesn't really look like a science documentary. It starts with chessboards, video games.
And Demis Hassabis isn't just some guy in a white lab coat.
Not at all.
No, his background is wild. It reads more like a hacker novel than a Nobel laureate CV. He was a child chess prodigy, number 2 in the world for his age at one point. But he was also a video game developer back in the 90s.
And not just any developer. The review specifically mentions he worked on the Class Brain theme park. And I have to pause here because I vividly remember playing Theme Park. I spent hours on that game.
Oh, wow.
You're building roller coasters, you're managing ticket prices, you're hiring janitors to clean up vomit on the sidewalks.
It sounds trivial, doesn't it? I mean, when you put cleaning up virtual vomit next to curing diseases, there seems to be a little bit of a disconnect.
A huge disconnect. It feels like a waste of time.
But think about what a game like Theme Park actually is structurally. It's a simulation. It's a closed economy with independent agents, the little visitors, who react to your decisions.
Right.
If you put more salt on the fries, people get thirsty and buy more soda. If the lines are too long for the rides, they get angry and they leave. It's a complex system of inputs and outputs.
So for him, he wasn't just designing a toy. He was building a sandbox for behavior.
Exactly. And that concept of the sandbox is absolutely crucial to understanding DeepMind's eventual success. To the outside world, games look like entertainment. But the documentary makes the case that to Demis, games were the perfect training ground for intelligence.
Okay.
When they started building their AI, they didn't just toss it into a biology textbook on day one.
They didn't start with the hard stuff. The source actually lists the training regimen. They used Atari games like Space Invaders, Breakout, then they moved to StarCraft, and eventually the ancient board game Go.
Think about the logic there. Why start with Atari? Why not just simulate a biology lab from the get-go?
Well, based on the review, it sounds like it's all about the cost of failure.
Yeah, precisely. If you're training an AI in the real world, let's say a self-driving car, a mistake means you crash into a wall. It's expensive. It's dangerous.
For sure.
But inside an Atari game, you can die 1,000,000 times in a second, and who cares?
The review has this great line. It says, the AI could fail millions of times in a game so it wouldn't fail when it mattered in the real world.
It's a playground. The data is rich, the feedback is instant, you get a score, and the consequences are 0. But I want to touch on StarCraft specifically because that was a huge leap from Atari.
Oh yeah, StarCraft is a different beast entirely. Atari is about twitch reflexes. StarCraft is, well, it's strategy.
It's more than that, though. Chess and Atari are games of perfect information. You can see the whole board. You know exactly where the enemy is.
Right.
Biology isn't like that. Biology is messy. You don't know what's happening inside every single cell. And StarCraft has the fog of war.
Ah, right. You can't see what the opponent is building until you send a scout out. You have to make decisions based on incomplete information.
Exactly. So by mastering StarCraft, the AI wasn't just learning to click fast. It was building the cognitive muscles to deal with uncertainty, to plan long term, and to manage resources under pressure. If you can build an algorithm that masters StarCraft from scratch,
You haven't just built a game bot.
you've built a general-purpose learning system.
Wow. That is a massive distinction. So they weren't building a machine to play games. They were using games to build a machine that could learn anything.
Yes, they were training the brain in the gym before sending it to the Olympics.
So that's the wow. They use games as this data-rich sandbox.
Yeah.
But the where is also really emphasized in this source material. And I think this is something a lot of people might miss. When you think of cutting-edge AI, the future, the singularity, where do you picture?
San Francisco, Silicon Valley, Palo Alto, that's the center of gravity.
Right. But DeepMind isn't there.
No. And that was a very deliberate, very strategic choice. The documentary highlights this. Despite the pull of the valley, Demis insisted on building DeepMind in King's Cross, London.
Why? I mean, usually you want to be where the money and the talent are all swarming.
The key word there is swarming. The source describes the valley as having a frenetic hype cycle. It's incredibly noisy.
It is. I mean, you think about the startup culture there.
Yeah.
It's just so fast.
It's fast, but it's often short-term. You raise a round of funding, and suddenly the clock is ticking. You need to ship a product, show user growth, pivot, monetize. It's all very quarter to quarter. But scientific breakthroughs, real Nobel-level breakthroughs, they don't run on quarterly cycles.
You can't schedule a eureka moment for Q3.
Exactly. Demis wanted to insulate his team from that pressure. He wanted to block out the noise and create what he called a hybrid culture. This is a really key concept from the review. He wanted the best of both worlds.
Okay, so what does that hybrid actually look like?
Well, on one hand, you have the long-term deep thinking of a university academic department, the kind of place where you can think about a single problem for 10 years without someone asking, so how do we sell this?
But academic departments can be slow. They can be, well, a bit dusty.
Right, which is why he combined it with the incredible energy of a startup, that urgency to get things done. But by being in London, physically removed from that echo chamber in California, they could control the dial.
The review uses this phrase I love, environment engineers culture.
It's so true. Sometimes to hear the signal, the real scientific signal, you have to physically distance yourself from the noise of the industry. I mean, if they had been in Palo Alto, would they have had the patience to stick with the gaming phase for as long as they did?
That's a great question. Probably not.
Or would the investors have pressured them to pivot to something more commercial, like an ad targeting algorithm, within just 2 years?
It's like they built a monastery for AI research in the middle of London, a place where they could really focus on the long game. And, speaking of the long game, let's get to the actual problem they solved. Because we keep saying protein folding, and I feel like we need to really unpack what that is.
Right. This is the meta problem they tackled.
The source calls the challenge the Olympics of protein folding. The event is called CANSP Critical Assessment of Structure Prediction, which, I'll admit, doesn't exactly roll off the tongue like Super Bowl. But in the biology world, this is it.
It is. And here's the context the source gives us to understand why this was such a monster of a problem. For 50 years, scientists have known what proteins are made of. We know the chemical ingredients, this long string of amino acids.
So that's the 1D information, like a list of letters.
Exactly. But proteins don't just sit there in a long line. They fold up into these incredibly complex, tangled 3D shapes. And the shape is everything.
Why does the shape matter so much?
Because in biology, structure is function. It's like a lock and a key. If you don't know the exact 3D shape of the key, the protein, you don't know which lock it opens. You can't design a drug to bind to it. You can't understand how a disease changes its shape. If you don't have the shape, you are just flying blind.
So the problem is, I give you the string of ingredients, you tell me exactly how it folds. Why was that so hard for computers? I mean, computers are good at math.
It's the sheer number of possibilities. It's a famous paradox known as Levinsol's paradox. A typical protein could theoretically fold into more variations than there are atoms in the known universe.
Wait, hang on. Really? More than atoms in the entire universe?
Yes. So if you tried to use a supercomputer to just guess and check every possible fold to find the most stable one, Well, it would take longer than the age of the universe to finish.
Okay, so brute force is completely off the table. You can't just calculate your way through it.
Exactly. So for decades, scientists were just inching forward. They'd use things like X-ray crystallography to take basically pictures of proteins. But it's slow. It's incredibly expensive. It could take a PhD student their entire academic career just to map one single protein structure.
So enter DeepMind. They've finished playing Space Invaders and Go. Now they look at biology. But they didn't try to solve protein folding the way biologists were trying to solve it.
No. And this is the absolute genius of their approach. They didn't try to hand code all the laws of physics into the computer. They treated it as a pattern recognition problem.
Like a game.
In a sense, yeah. Their hypothesis was, if we can solve intelligence first, if we can build a general purpose learning system, we can just point it at biology and it will figure out the rules.
That's the meta part. They weren't building a protein solver. They were building a brain AlphaFold that could learn to become a protein solver.
The review uses this analogy that I think is just perfect. It says, don't just chip away at the obstacle, stop, step back, and build a better chisel.
That is the ultimate engineering mindset. I mean, most researchers were busy banging their heads against the wall, trying to solve one protein at a time. DeepMind spent years building a sledgehammer. And when they finally swung it, the wall just crumbled.
The results were insane. They didn't just win the CASP competition, they blew everyone else out of the water. They achieved accuracy that was comparable to high-tech physical experiments.
And the scale of what they released is just hard to wrap your head around. The source mentions they open-sourced a database of over 200 million protein structures.
Just think about that number for a second. Before AlphaFold, humanity had mapped maybe a couple 100,000 structures over the course of 50 years. DeepMind released 200 million. They effectively mapped the entire protein universe known to science.
It's like going from having a hand-drawn map of your backyard to suddenly having a high-resolution GPS map of the entire globe just overnight.
Exactly. And this totally validates that sandbox approach we talked about. If they hadn't spent all that time mastering the fundamentals of learning through games, learning how to learn AlphaFold wouldn't have been capable of this complexity.
It really connects everything. The play, the strategy, the location, the science. It all clicks.
It does. It shows that the lightning strike was actually 20 years of cloud seeding.
Now, I want to pivot to the documentary itself, The Thinking Game, because the source really emphasizes that this isn't some dry educational film. Gaurang calls it a thriller about the creative process.
Which is a genre we don't see nearly enough of. We see thrillers about crime or spies, but a thriller about thinking.
Yeah.
About the tension of engineering. That's rare.
The review describes the climax of the film, watching the team's reaction as the CASP results come in. And we have to remember, these are real people. They've poured years of their lives into this black box, staking their entire reputations on the idea that an AI trained on games could outsmart traditional biology.
That's the human element, the emotional payoff, as the source calls it. You're watching these scientists and engineers realize in real time that they haven't just won a contest, they've just changed the course of medicine.
I can only imagine the feeling in that room.
It changes your perspective on what an impossible problem even looks like. When you see the finished product, Nobel Prize, the headlines, it all seems inevitable. But the documentary, it shows the doubt. It shows the grind. It shows that success isn't just about being smart. It's about obsession and patience.
Kind of blurs the line between technical and creative. We often separate those things in our heads. Artists are creative, engineers are logical. But this story says no. Solving a problem like this requires immense creativity.
Absolutely. Designing the architecture of AlphaFold, deciding how to train it, choosing the right sandbox. Those are deeply creative decisions. You're navigating the unknown.
So let's bring this all together. We've covered a lot of ground here, from theme park to London to the Nobel Prize. If we look at the source material, this review of The Thinking Game, what are the big takeaways for someone listening right now? You know, maybe they aren't trying to fold proteins, but they have their own big, scary problems to solve.
I think there are three main pillars here that apply to almost any field. First, respect the value of play. DeepMind used games as a research sandbox. You have to ask yourself, do you have a safe place to fail? Do you have a playground where you can test ideas without crashing your whole operation?
That's number one. Build a sandbox before you build the lab. What's two?
Number two, the strategic value of your environment. Demis chose London over Silicon Valley specifically to avoid the hype. So you have to ask yourself, are you in an environment that supports deep work, or are you just surrounded by noise? environment engineers culture. Sometimes you have to physically move, or at least mentally distance yourself, to find the signal.
You have to protect your focus. Okay, and number 3.
Solve the meta problem. Don't just chip away at the immediate obstacle with the tools you already have. Sometimes you need to stop, step back, and build a better tool. Build the chisel. Build the general purpose learner. It takes longer up front, but the payoff is exponential.
It's the difference between linear work and exponential leverage.
Exactly.
You know, this whole discussion makes me think about how we view seriousness in our professional lives. We're so often told to put away childish things, stop playing games, get to work. If you want to change the world, you have to be serious.
It's a very pervasive cultural idea. We sort of equate misery with productivity sometimes.
Right. But looking at DeepMind, looking at this Nobel Prize, it leaves me with this one provocative thought. We assume that the next great breakthrough, the thing that saves lives or changes the world, is going to come from some sterile, serious, no fun allowed environment.
But the evidence here suggests the complete opposite.
Exactly. Perhaps the key to the next great breakthrough is hidden inside what we dismiss as play. Maybe the person playing a video game right now isn't wasting time. Maybe they're training for a problem we haven't even discovered yet.
It's a comforting thought, isn't it, that curiosity and play are actually the engines of progress.
It is. If you get the chance, the source highly recommends watching The Thinking Game. It's available from Google DeepMind. It sounds like it's well worth your time, whether you're into chemistry or code or just a good story about human potential.
Definitely. It's a rare look behind the curtain of genius.
That's it for this deep dive. Go find your sandbox, and we'll catch you on the next one.
Goodbye, everyone.